Did you ever wonder what happens to the bottles you throw away every day, the ones you just toss without a second thought? Believe it or not, those same bottles can come back to life in a factory. Every year, humans produce over 2 billion tons of waste, and almost 20% of that is glass. It's crazy to think that a single bottle can sit in a landfill for over 1 million years without breaking down. But here's the amazing part. Glass can be recycled forever without ever losing its quality. So how does this transformation actually happen? How do messy, shattered shards turn into clean, sparkling new bottles ready to be used again? Today we're taking you inside one of the world's largest glass recycling factories, where hundreds of tons of glass are reborn every single day, and we'll reveal the secrets behind this incredible journey of sustainability. Before we jump in, here's a quick note. If you love discovering how everyday objects are made and recycled, make sure you hit that subscribe button and turn on the notification bell for Factory Flow. You don't want to miss the behind-the-scenes adventures we bring straight to you, like the story of how a bottle goes from trash to treasure. And while you're at it, smash that like button if you're excited to see glass come back to life. Trust me, the next few minutes are going to blow your mind. The journey starts with collecting used bottles. In daily life, empty beer, soda, or juice bottles often get thrown in the regular trash, making recycling messy, complicated, and costly. But in many European countries, they've found a clever solution: reverse vending machines. You simply drop your empty bottle in, it scans and sorts it, and even gives you a small refund, usually 10 to 20 cents. This means that a bottle, fresh from your finished drink, isn't just waste, it's suddenly valuable, with cash in your pocket. Not only does this encourage people to collect bottles themselves, but it also gives factories a supply of pre-sorted, clean glass, ready to be recycled efficiently. Europe seems to have it all figured out. But what about the US? Do we have systems this advanced here too? Drop a comment and let me know. Once the reverse vending machines are full, collection companies send out specialized trucks to pick up the bottles. Each large plastic bin holds thousands of empties, and forklifts load them onto trucks. A single truck can carry 20,000 to 30,000 bottles, roughly 10-12 tons of material, heading straight from supermarkets and collection points to the recycling plant where the real magic begins. Each truck arrives packed with tens of thousands of empty bottles, stacked tightly in bins. When the drivers reach the massive storage bays, they back up and release the load, sending a tumbling cascade of bottles crashing to the ground. Within minutes, the floor is covered with mountains of colorful glass, sparkling under the lights, greens, browns, and clear bottles piled together like gems. But these aren't just random piles of waste. They're the starting point of the entire recycling journey, a steady supply of raw material waiting to be cleaned, crushed, and reborn. To begin the recycling process, massive loaders roll up to the towering piles of glass, scooping huge loads with their buckets and carrying them across the yard. With a thunderous crash, the glass is finally dumped into the plant's feed hopper, cascading down a steel chute. Instantly, the conveyor belts spring to life, carrying streams of glass mixed with dirt, sand, and other debris deep into the facility. The first stop is a vibrating screen, which shakes the glass with tremendous force, separating dust, grit, and tiny particles. After this stage, the glass is noticeably cleaner, but larger contaminants that machines can't easily detect still remain. Along the conveyor, workers stand ready, carefully picking out paper, plastics, and anything else that doesn't belong. This mix of mechanical screening and human precision produces a much cleaner batch, ready for the next step. But wait, there's still something hiding in that pile: bottle caps. Luckily, most are made of metal, which means they can be easily removed using a high-powered magnetic separator. The principle is simple: the strong magnetic field grabs the steel caps while the glass continues moving down the line. After this step, the glass is roughly 80% clean, one giant leap closer to being reborn. Next comes one of the most important steps: grinding the glass into cullet. The larger pieces are fed into a hammer mill, a massive machine with high-speed rotating hammers that smash the glass repeatedly until only tiny fragments remain. Any pieces that are still too large are automatically detected and sent back through the mill, ensuring that every fragment is the perfect size for melting. The hammer mill keeps crushing the glass until every piece reaches the perfect size, making the entire stream uniform with no stragglers slipping through. What this produces is cullet, fine, sparkling glass particles that almost look like man-made sand because they've been broken down so small. Cullet is a game-changer for recycling. It melts much faster in the furnace, saving up to 40% of the energy compared to using raw materials like sand or limestone. Once the glass has been ground, it's carried to a powerful suction system, where strong blasts of air strip away any leftover label fragments, leaving the cullet even cleaner. Then comes one of the most precise steps of the entire process: the optical sorting system. As the cullet cascades down like a shimmering waterfall, laser sensors scan each tiny fragment to detect its color and composition. The moment brown, green, or even a stray ceramic piece is spotted, a precise puff of air shoots it into a separate stream. The speed is incredible. Tens of thousands of pieces are sorted every single minute. This step ensures that the cullet is perfectly separated by color, because even a tiny mix-up could ruin the quality of recycled glass. Once sorted, the cullet moves along the conveyor into separate storage areas, each color kept apart. There, it slowly piles up into massive stockpiles, patiently waiting to be transformed into brand new glass bottles, ready for the next stage of the recycling journey. Once the cullet is sorted and ground, it can't go straight into the furnace. First, it needs to be blended with raw ingredients. The mix begins with pure silica sand, the key ingredient that gives glass its clarity. Then comes soda ash, or sodium carbonate, which lowers the melting temperature and saves a ton of energy throughout the process. Limestone is added as well, strengthening the glass and making it more stable once it's formed. In some formulas, manufacturers also include dolomite, alumina, or metal oxides to tweak the color or other properties. But the most important part is still the cullet, which can make up 20 to 70% of the batch. This helps the melt flow faster and cuts energy use by up to 40% compared to brand new raw materials. In fact, adding just 10% more cullet can reduce energy consumption by about 3% and significantly lower CO2 emissions. Once all the ingredients are carefully measured and mixed according to the factory's formula, the blend is ready for the furnace. The mixture is poured into a massive gas furnace where temperatures soar to around 1250 degrees Celsius, hotter than molten lava from a volcano. Technicians monitor the process closely, carefully pouring the mix into special crucibles inside the facility. Workers wear fireproof suits and heavy gloves because the surrounding heat, nearly 3,000 degrees, is almost unbearable. The mouth of each crucible is sealed to maintain the extreme heat and control the melting process. After about 24 hours, the mixture is no longer sand. It starts to flow thick and glowing like lava. At the bottom of the furnace, the brilliant molten mass shimmers, dense, shiny, and ready to be shaped into brand new glass bottles. By now, the molten glass has reached the perfect temperature and viscosity, and it stays in this glowing liquid state for the next 5 hours. During this time, any remaining gases escape, ensuring the final material is as pure as possible. But molten glass alone isn't enough. It needs a mold to take shape, which makes mold creation the next crucial step in the process. Engineers start by designing molds using advanced CAD software, carefully controlling every line, curve, and thickness to meet exact technical standards. Once the digital design is finalized, the molds are manufactured from cast iron or alloy steel, materials strong enough to withstand temperatures up to 1400 degrees Celsius. These molds are then prepared to receive the molten glass and form it from the inside, giving each bottle its perfect shape. When the molds are ready, they're installed into a double-blow production line, one of the most reliable methods for shaping hollow glass products like soft drink bottles, food jars, and pharmaceutical containers. The process begins by dropping molten glass, called gobs, into the initial blank mold. These gobs are cut from a continuous stream of liquid glass at around 1011 degrees Celsius, with just the right viscosity for smooth, consistent shaping. Inside the preliminary mold, a jet of compressed air pushes the molten glass outward, forcing it against the walls of the mold. This forms the initial shape, known as a parison, a hollow bubble-like structure with a narrow neck, still glowing with intense heat. The parison is then gently transferred to the final mold, sitting just a few inches away on the same production line. Here, a second burst of compressed air is shot directly into the center of the parison, stretching the softened glass outward until it presses tightly against every contour and detail of the mold's inner cavity. In just seconds, the full shape of the bottle is formed. From the outside, it may look fast and effortless, but behind the scenes, every movement is timed with incredible precision. Every valve, sensor, and mechanism is timed with incredible precision, synchronized down to 1,000th of a second. This extreme level of control is what makes it possible to manufacture hundreds of thousands of bottles per day, each one nearly identical and flawless, as if they all came from a single perfect mold fresh out of the oven. The glass bottles glow with a deep red heat, their surfaces shimmering in the dim light like glowing metal rods. Robotic arms glide in with programmed precision, lifting each bottle carefully and placing it gently onto the conveyor belt. The entire scene unfolds in calm, synchronized silence, without a hint of rush, yet operating at mind-blowing efficiency. The conveyor belt slowly guides the newly formed bottles, their bases still glowing, toward the cooling area. They travel through a long yellow tunnel, where the temperature gradually drops, giving the glass time to settle safely without cracking. This careful cooling process can take several minutes, and sometimes even stretch to tens of minutes, depending on the bottle size and shape. Once cooled, the bottles reach the inspection stage. Here, an array of optical sensors and high-speed cameras examines each bottle in real time, checking every detail. The moment a defect appears, whether it's a crack, bubble, scratch, or even a tiny warp, the system immediately flags it and removes the bottle from the line. Next comes a closer inspection of the bottle's mouth. Each bottle is rotated with precision by an automated system, while optical sensors and mechanical probes team up to detect chips, fine cracks, or the smallest deviations in dimension. Only bottles that pass this strict scrutiny are allowed to move forward, ensuring that every single product leaving the line is perfectly made and ready for use. After passing all inspections, the glass bottles are carried to the palletizing section, where robotic systems take over. These machines are designed for perfect accuracy and uniformity, effortlessly organizing thousands of bottles at a time. A clamp mechanism with suction cups gently lowers, grips a full row, and carefully places it onto the pallet layer. To protect the bottles during handling and shipping, sheets are placed between each layer. Once the stack is complete, an automated wrapper secures the pallet in film and tags it with a production code, linking it to its specific batch. Finally, the glass pallets are moved into storage, neatly stacked and ready for shipment. From here, they will travel across the globe, soon to become sparkling new bottles, filled to the brim and ready to serve in every corner of daily life. Of course, glass bottles are made to hold drinks, and let's be honest, almost everyone has had a Coca-Cola at least once in their life. These iconic glass bottles go through a highly controlled bottling process before reaching the shelves. First, each bottle is thoroughly cleaned using high-pressure hot water and steam to eliminate any dust or bacteria. Then they move along a high-speed conveyor to the filling station, where automated nozzles fill each bottle with Coca-Cola down to the exact milliliter. At the same time, CO2 gas is injected to lock in that signature fizz. Immediately after filling, the bottles head to the capping station, where crown caps are pressed on with extreme precision. Each cap undergoes a detailed inspection for tightness, using high-precision sensors integrated into the line. This ensures every bottle is perfectly sealed, preventing even the tiniest leaks before the bottles are packed and shipped out to stores worldwide. Next, each bottle passes through a high-speed camera system that checks for cracks, overfilling, or misapplied labels. The Coca-Cola bottles continue to glide smoothly along the conveyor belt, perfectly lined up like a programmed assembly, moving through each stage with steady, precise rhythm. At the water spray station, a high-pressure jet of cold water is aimed directly at the neck of each bottle, ensuring they are completely clean and ready for the next step. Finally, the perfectly sealed bottles are packed into cartons, loaded onto pallets, and moved into cold storage, ready to be shipped to millions of stores around the world, from small roadside shops to luxury hotels. And just like that, the glass's journey of rebirth comes to an end. What was once broken shards of waste rises again to become something shiny, pure, and full of value. Recycling glass into brand new bottles isn't just a win for the environment, it's a reminder of the magic behind modern technology. We hope this video inspires you to make glass recycling a habit in your own life. Drop a comment below and let us know your thoughts. Don't forget to like, share, and subscribe to Factory Flow to keep exploring more fascinating industrial journeys and uncover the secrets behind the world around us.